so let's roll along and actually have a look at some of these elements and see.
Oh, look at that. That's great.
So this has probably never been seen. If we just sort of stop there for a moment, actually all these little edges and all these little devices that we spend so much time looking at and wondering exactly what they do, this is what's happening. Each of them is creating a vortex from the sharp edges.
So, for example, the inboard edge of the front wing, the air cannot go through those physical wing sections. It has to find a way around. And the way they're sloped helps the air to make a start. Then you're creating high pressure on the outside. You imagine pushing your hand into the airflow. The air doesn't, you're forcing the air out of the way. It's got to find a way around. But also the underside, with each slot gap, the underside is accelerating the air underneath. So you generate a nice suction underneath, positive pressure, and the air will find its way around. And that's exactly what this animation is showing, that the air is finding its way around each element, rolling up a nice little individual vortex, and they all roll around one another. It's really exciting to look at in real life when you have the right, if you like, airflow tools to be able to watch it. And they roll up into this great big Y250 vortex.
Okay, so
I remember when this rule first came out, we were asking ourselves a question: do you want to weaken the vortex and have nice clean airflow, or do you want to strengthen it? And it didn't take very long at all to work out, actually, you want the strongest, most powerful vortex you can get.
Okay, so let's run this on. We can see this, all the air spinning into these big airflows.
If we pause it again, if I just point out the deflectors, if you like, the turning vanes on the upper stack of the front wing, each one is, roughly speaking, vertical. And they are turning the air. So the air coming towards these turning vanes, can't go through, is forced to go around, will find a way to roll up over the top. Again, with a curved surface on the back, you're trying to accelerate the air, so you have positive pressure the one side, negative the other, a nice little but quite strong vortex, and they also merge together and they co-rotate with the vortex that's created on the inside. And then the big vortex rolled up by the end plate rotates the opposite way. So you can imagine these deflectors going this way, the air has to go around that way. So these vertical ones roll the air up that way. Those roll the air up the opposite direction.
I see. And that pushes all the air. And if we just now take a broader view of the car,
this is great.
We can actually see that it's all going outboard of the rear wheel, and this rear aero, which is so important for reducing drag in order to run the smallest possible wing for the best aero efficiency. It's all working.
To be fair, a Formula One car is not about low drag. A Formula One car is about tons, and
depends
literally
the engine you have.
It depends. But the Formula One car is about generating tons of downforce to push the car onto the ground so it goes around the corners. And so if you look at a modern road car, they're going to have drag coefficients well under 0.3. And especially a Formula One car, it's actually not so big. But let's look at just the coefficient, ignore frontal area. A good road car, well under 0.3. 0.23 is something that you can buy for not super money, if you know what I mean, not having to go exotic. A Formula One car is going to be somewhere between 0.7 and 0.9. It's huge, and depending, now the teams play a game a little bit with their coefficients because they use an unrealistic frontal area. So normally you multiply the frontal area of the car times the drag or downforce coefficient. And if you adjust the rear wing, you're going to change the frontal area. The teams don't bother. Why would you bother changing? They're only looking at the total. So they use an unrealistic frontal area so their coefficients don't look so good. So if they say we've got a drag coefficient of 0.9, it could be that actually they're working with a frontal area that's bigger than the real front. Do you know what I mean?
Yep. Play with numbers. Excellent to see these visuals for the first time
really
accurately,
good.
And obviously excellent for your insight to explain what's such a complicated section of the car.
It is complicated, but if you break it down to one part at a time, I think it's actually quite understandable. One can understand it piece by piece.